Welcome back to The Explainer. Today, we are digging into a fascinating research paper from 2025 that basically shows us how to turn a regular kitchen appliance into a full-blown, high-performance ceramic kiln. Seriously, this could change everything for artists and makers.
Look, if you've ever worked with clay, you know the biggest bottleneck is the kiln, right? They're slow, they're expensive, and they use a ton of energy. Firing a single piece can take up your entire day. But what if? What if you could shrink that whole process from a grueling 8 to 10 hours down to about an hour? Yeah, about the time it takes to watch a movie.
This is that classic problem for every potter. You're constantly waiting, paying high energy bills, and you need a dedicated studio space. But what if the solution to all that is already sitting on your kitchen counter? Let's dive in.
Okay, so get this. Researchers took standard, off-the-shelf microwave ovens and managed to turn them into ceramic kilns that can reach incredibly high temperatures. But to do that, they had to solve one major problem. How in the world do you safely contain that much heat?
Now you're gonna love this. The secret actually came from a totally different piece of tech, the rocket stove. And it just goes to show, the core principle is universal. If you want to get something crazy hot, you have to be amazing at trapping that heat.
And here's exactly how they did it. It's a brilliantly simple idea, really. First, you just pop out the turntable to make some room. Then, you build a kind of insulated box within a box. They use a special fiber blanket for the outer layer, and then line the inside with refractory bricks. This little fortress is what lets the chamber get hot enough to actually vitrify porcelain, which is just a fancy way of saying it melts the clay into a solid, glass-like state.
Okay, let's be super clear here. We're talking about incredibly high temperatures and microwaves, so safety is everything. This was a serious scientific experiment, not some weekend DIY project. The researchers went to great lengths. They kept all the original door safety switches. They hunted down and shielded every single microwave leak with professional gear, and they even added extra fans to keep the electronics from frying.
So here's the interesting part. A microwave on its own can't really heat up cold clay. At room temperature, most ceramics are basically invisible to microwaves. You need something else, a special component to really get the fire started. Let's see what that is. And that special component is called a susceptor. The easiest way to think about it is like the engine of the kiln. It's a material that's specifically designed to soak up microwave energy right from the start, get glowing red hot, and then it just radiates all that heat onto your ceramic piece.
And what's really amazing is that the researchers came up with a super simple, workshop-friendly way to make these little engines themselves. You just mix 2 common mineral powders, silicon carbide and magnetite, with a bit of water, pour the slurry into a mold, and then fire it for about 10 minutes in the microwave kiln itself.
And this is where the real magic happens. In just those 10 minutes, a wild chemical reaction completely transforms those simple powders. The magnetite literally vanishes, reacting with the silicon carbide to forge a totally new, high-tech material. This matrix of ferrosilicon and cristobalite that is just perfectly designed to absorb microwave energy. It's pretty incredible.
But it gets even better. They discovered that not all susceptors have to be the same. Just by tweaking the recipe a little, changing the ratio of the 2 powders, they could create 2 totally different types. And this gives the artist a really powerful choice. So, you've got 2 options. On one side, you have the workhorse. It's low in magnetite, which makes it super durable. It gives you stable, predictable heat for over 100 firings. Perfect for everyday stuff. But then, you have the alchemist. This one is rich in magnetite. It doesn't last as long, maybe 10 to 15 firings, but it gives you a kind of superpower. It can create a low-oxygen atmosphere inside the kiln. This is huge because it lets you get those stunning, complex glaze effects that you usually only see from a gas-fired kiln. Okay, so you've got your modified microwave, you've made your own custom susceptors. The big question is, what are the results actually like? Does it really work? Well, first off, the time savings are just nuts. I mean, look at this. A process that used to lock up your entire day is now done in about an hour. That is a massive difference.
And yep, it gets plenty hot. The kiln reliably hit 128 degrees Celsius. That's more than hot enough to fully vitrify even really demanding clays like porcelain, giving you pieces with fantastic mechanical strength.
And to make sure they weren't just imagining things, they had professional ceramicists check out the finished pieces. And the verdict? They loved them. They praised the quality, the look, and the feel. They even said that some earthenware pieces had that signature ring to them, that they sounded like porcelain.
But of course, the real proof is in the pudding.
or in this case, the pottery.
And they fired a whole range of things. Everything from these large 21-centimeter decorative bases and candle holders all the way down to delicate porcelain butter dishes. The kiln handled it all, producing beautiful pieces with zero defects.
So, what does all this mean? What's the big picture here for the future of pottery and small-scale craft?
Well, the researchers themselves conclude that this isn't just some clever parlor trick. This is a genuine step forward. That ability to control the kiln's atmosphere, to get those gas kiln effects with just electricity, that could be a real new advancement for the world of ceramics.
It really puts the power back into the hands of the artist. It gives you incredible speed, amazing efficiency, and a whole new level of creative control, right in your own home or workshop. So it leaves us with this one really exciting question to think about. What could you create if you could take an idea from a lump of wet clay to a finished, fired piece, not in days, but in a single afternoon?